Okay. I assume you guys can hear me based on the little microphone moving. So we'll go ahead and get started. What I thought we would do first is go over quiz 3, and everybody did real well on it because everybody could take it as many times as they needed to, I think, is what it ended up being. But some people have expressed some challenges with the fact that we have like 16 options. I don't know how many there was on that quiz, but some frustrations on how to do how to like come up with the right answer. And so I thought what we'd do is go through that first, and you guys can stop me if you have questions. And this is basically the reverse of how I make the quizzes. And so I come up with all the answer choices, and then I write the questions, and then I select the right answer based on the answer choices. So we'll start. And the first question is, what products of protein digestion are absorbed from the rumen of the mature cow? And what I do is I go through and say all the things that I know for sure aren't. So, and this is how I would take the quiz if it was me. So I would say I know amino acids aren't, I know dipeptides aren't, I know tripeptides aren't, I know ammonia is, I know urea is not, I know VFAs are, I know pepsin is not. Okay, so then I just have to look for the choice that says ammonia and VFAs. I need to write the letters. And so I'm looking for D and F, and so D and F is there. So that's the one I would pick. Okay, so when we do quizzes or the multiple choice portion of the exam, because you have unlimited time, I would make something similar. It doesn't have to be quite that, but something similar to that. Okay, and so we'll maybe do 1 or 2 more, and then we'll be done, unless you guys want me to do them all. So which one or ones can directly require sodium to be transported into the enterocyte? We know that amino acids are yes, dipeptides, not directly, it's indirectly, because we're going to use a proton actually, and then we're going to use sodium to pump that proton out. Tripeptides, the same thing. Ammonia, not absorbed into the enterocyte, so no. Urea, not absorbed into the enterocyte. VFA, not really absorbed into the enterocyte. And pepsinogen, not really absorbed into the enterocyte. So I know the right answer is just amino acids. Okay, I need to shut my email off this way. Okay. Well, yeah. Okay, and then number 3 would be, which one contains or ones contain crude protein, but no actual amino acids? So I know amino acids contain amino acids. I know tripeptides or dipeptides contain amino acids. Tripeptides contain amino acids. Ammonia contains nitrogen, so it would have crude protein, but it contains no amino acids. So we know that that one is correct. Urea also contains nitrogen, but no actual amino acids. So we know that one's correct. A lot of people stumbled on pepsinogen. So pepsinogen is an enzyme, and an enzyme, oh no, we're doing VFAs. No, and then VFAs don't contain nitrogen, so they're not crude protein. Pepsinogen, people stumbled on pepsinogen. So pepsinogen's an enzyme. Enzymes are made of proteins. Proteins are made of enzyme, or proteins are made of amino acids. So it contains crude protein, but it also contains amino acids. So the right answers are D and E, and so we pick D and E. Okay, do you guys want me to do the rest of the questions? Or are we good? There's only 8 of you, so one of you will have to decide who's going to speak.
Can you please do the rest of the questions?
Okay, thank you, Lauren. So question 4, which ones are secreted into the lumen? So lumen, sometimes a tricky word for y'all, because you generally think of the lumen as the small intestine, but the lumen's the entire gastrointestinal tract. So the entire hole, like the empty spot in the gastrointestinal tract. So we're looking at things that are secreted into the lumen. So that would be the rumen, the abomasum, reticulum, omasum, small intestine, large intestine of a cow. Okay? And we know amino acids are not. We know dipeptides are not. We know tripeptides are not. We know ammonia is absorbed, but not secreted. So no. Urea, we know it is secreted because we have arrows drawing it into the saliva and into the rumen and into the large intestine. So we can write yes. We'll write no for VFAs, they're absorbed. And we know pepsinogen is a zymogen that's secreted into the stomach. So yes. So then we look for E and G. And E and G is way down here because I realized I needed it. So I had to add it at the end. So that's the one we would pick. Question 5. A lot of people ask questions about this. Which one or ones contain at least one peptide bond? An amino acid contains no peptide bond. A dipeptide contains one peptide bond. A tripeptide contains one peptide bond. Ammonia, no. Urea, no. VFA, no. And pepsinogen, we just said pepsinogen is a zymogen. Zymogens are enzymes. Enzymes are made of proteins. Proteins are made of amino acids. So therefore, we know that that contains at least one peptide bond. So we look for B, C, and G. And we have B, C, and G. Okay, what products of protein digestion are absorbed from the small intestine of a quarter horse? It doesn't actually matter that it's a quarter horse, because anytime I ask this question, the answer is going to be the same. And so the products absorbed, we know amino acids are, we know dipeptides are, we know tripeptides are. Ammonia is not, urea is not, VFA is not, pepsinogen is not. So we're looking for A, B, and C. And so bam, A, B, and C. Okay. What products of protein digestion are absorbed from the small intestine of a mature cow? And the answer would be the same because it's small intestine. What products of protein digestion are absorbed from the large intestine of a draft horse? So basically we have to think about a large intestine being like a rumen or real similar in kind of what happens from a protein digestion standpoint. We know amino acids aren't absorbed. We know dipeptides aren't absorbed. Tripeptides aren't absorbed. Ammonia is absorbed. Urea is not absorbed. VFAs are absorbed. Pepsinogen is not absorbed. So we're looking for F and D, or D and F. And so we check that one. What products of protein digestion are absorbed from the large intestine of the cow? Same thing. Okay. Does anybody have any questions on the quiz? Anybody think the quizzes are terrible? You don't have to answer that, but you can. The quiz that I made today for lipids is real similar. There's lots of choices. I don't think I use the exact same choices for every question, but there's lots of choices. So I'd make like a matrix or a grid like this to help me find the right answer. I would do the same thing on a real multiple choice test like that we would take in class, but it wouldn't have to be nearly complex because there were only 5 choices. And so now you have, I think I can go to 26 choices. I haven't written one with 26 choices yet because that seems excessive. So I think 16 is the max that I have. Okay, any questions about that? Okay, I think the exam is going to be available starting Sunday evening. You need to be done with it Tuesday evening. The exam will probably be 20 to 30 multiple choice questions. And I think 5 to 10 Short answer. How do you spell answer? Short answer questions. And when I mean short, I mean like short. I don't want you to write a book, and I will make that clear in the note, like in the instructions for the exam. But I don't want it to be super, super long or involved. A couple sentences should answer them. The ones I've made so far, basically I can answer in incomplete sentence form in about 10 words generally. So a couple sentences, 2, 3 should be good. Okay. And if you provide extraneous information, I will grade that information to make sure it is right. And so the way we're going to do the grading, just so you know, is Jody's is grading the activities, and Tryon, that's me, is grading the exams. But if you want to complain about the activities and how they're graded, you can complain to me. So, and that's the exam. So Sunday through Tuesday. And my goal is to get them graded pretty quickly because I just don't want to be any further behind than I already am. Okay, does anyone have any questions about protein? This will probably be the last time we talk regarding protein or before you guys take the exam. And so if you have questions, now would be a good time to ask those questions. If you don't have questions, I'm going to go eat ice cream.
I have a question.
Okay.
So in the large intestine and the rumen, the VFAs are made by ATP and carbon skeletons, correct?
So the VFAs, so when we take an amino acid, that's a good question. When we take an amino acid, we're going to break it down. The microbe's going to degrade it. And when they degrade it, they're going to produce ammonia, right? And a carbon skeleton. Okay. That carbon skeleton can be further broken down into VFAs. Or it
Will you
becomes
scoot it up?
Yes. Sorry. Thank you. Your dog's noisy. So, and in the process, the microbes take ammonia or take ATP. The microbes get some energy. There are these microbes. We don't really talk about them, I don't think. There are these microbes in the rumen that all they do is degrade protein. They're hyperammonia producing bacteria. And so all they do is degrade protein. And from that degradation of protein, they get ATP. And they use that ATP to grow and do microbial things. Like stay alive. And growing is reproducing, right? So I need to scoot over. Did that help, Marion? I think that's...
So I think in the videos you said that you had to take ATP to make the VFAs from carbon skeleton. I didn't know that you broke down this carbon skeleton to make
Yes,
VFAs.
the microbe's getting ATP from taking amino acids to VFAs. Now, if we go the other way, if the microbe is taking a carbon skeleton and an ammonia and making an amino acid, that requires ATP. Does that make sense? Because we're building something. When we're taking something apart, we generally get energy from that. When we're building something, we require energy.
Okay, so the VFA is a component of the carbon skeleton.
Yes. Yes.
Okay.
Yes, exactly.
Thank you.
Some of them are the same. Like they're automatically VFAs. Bam, they have a VFA. We don't learn those because they're called the minor VFAs. And so we don't actually learn them. We just learn the 3 big ones.
I have kind of a curiosity question.
Okay. You know what happened to the cat?
What?
I said, you know what happened to the cat?
Okay. When we're talking about DIP and UIP, what kind of do would those be? Like what feed material would that be?
Okay. So DIP and UIP. So there are a few sources of feed that we can think of as being 100% DIP. And the 100% DIP ones are urea and ammonia salts and some other non-protein nitrogen, NPN. I don't think we talked much about NPN, non-protein nitrogen, because that's something I usually like go off on a tangent about one day in class. And the sterility of this process makes it hard for me to go off on tangents. But NPN would be those. So there's 100% DIP. And then there are maybe, I don't know if it's even 100%. We'll say greater than 90% UIP. And so that the best example, we don't feed it a lot anymore, would be feather meal. So feather meal contains a lot of UIP. And then everything else exists on a continuum between those two. And so if we look at soybean meal, because we like soybean meal, it's probably 70% DIP and 30% UIP. Okay, and there are factors that affect the ratio of DIP to UIP. And some of those are feed, characteristics of the feed, like they're inherent to the feed. Another one is rate of passage. And so in the feed, we look at KD, and that would be the rate of degradation. And so if we have a slow rate of degradation equals increased UIP. Fast KD equals increased DIP. And then the opposite's true with slow KP. We have increased, slow rate of passage. We increase the DIP because the protein source is spending more time in there. And fast KP equals increased UIP because the feed stuff's not spending as much time in there, and so it can't be degraded. So we look at like urea. Urea has a, and this doesn't mean anything, but urea has a KD of 300. So 300 means it's all essentially degraded instantaneously. And like feather meal might have a KD of 2 or 3% per hour. So it's really not degraded ever. So every feed, almost every feed, contains a mixture of DIP and UIP. And it kind of depends on you know, how that feed's processed, how you handle that feed, that dictates the amount of DIP to UIP. Did that answer your question?
Yes, it did.
Okay, might have been a longer answer than you wanted.
What did you say NPN was?
Non-protein nitrogen?
Okay, thank you.
And so non-protein nitrogen is anything without amino acids linked together by peptide bonds. And so it has a really rapid rate of degradation. The one we feed the most is urea. And so you can buy urea as fertilizer, right? You can buy fertilizer and you can feed it to cows and they can use that to meet their nitrogen requirements, which is amazing. That's why I love cows. Well, lots of reasons, but that's one of them. Okay, you can give them fertilizer and they can produce protein and live and stay alive. Okay, other questions? You can also kill them with non-protein nitrogen too, so you have to be careful. They will die. They'll die of urea toxicity, which is actually ammonia toxicity, but you have to work really hard at it. You have to really screw up. But you can do it if you try hard enough. Anything else? Okay, I have a question. Is it going okay? Like I'm flying completely dark because I don't even see any faculty members, which is okay because faculty aren't exactly cool people anyway. But is this working? Do I need to change anything? Everybody's good? No one complained. I mean, a few people complained, but they complain about the papers and stuff, not about anything substantive that I can change.
I would say it's going well. I think the videos are helpful, and then I like the Q and answer sessions as well.
Okay. Okay. If no one else has questions or comments, or if you want me to talk about anything, you need to ask.
I have a quick question about the brush border peptidases.
Uh-huh.
Those are being secreted from like the small intestine, like the enterocyte. Where do those come from exactly?
They come from the enterocyte. Perfect. So yeah, the enterocyte makes them, and they just basically make smaller pieces to be absorbed.
Okay, but those aren't on the inside of the enterocyte. They're in the small intestine, right?
Correct. They're made by the enterocyte, released in the small intestine, except the one inside the enterocyte peptidase.
Okay, perfect. Thank you.
That one stays inside the enterocyte to make dipeptides and tripeptides into amino acids.
Yes. Okay, awesome.
Okay. Perfect.
Going off of her question about the brush border peptidases, what
Yeah.
makes enterocytes secrete them? Like, does it respond to anything?
That's a really good question that I've never thought to try and answer. So my guess is, and this is a guess, an educated guess, but my guess is it's in response to the SNI cells secreting CCK and them secreting secretin and CCK, and just the presence of the protein in the small intestine causes the enterocytes to release those enzymes.
Okay.
Do you have another question, Madeline?
No, I didn't. I was just going to make sure you knew I understood.
Okay, are you sure?
Yes.
Okay. We did interviews for a student organization, and we had to do them on Zoom, and I asked a lot of questions very rapidly, and apparently it was somewhat intimidating. But I also had to interview 2 potential grad students on Zoom, so that was also intimidating for them because they don't actually know me, and it was intimidating for me because I don't like to be on the computer where I can see myself.
I had to do an interview video for a class, and so my dad had to fake interview me, so that was a little nerve-wracking.
Your parents are the worst. Not yours in particular, just parents in general are hard to give presentations to.
Mm-hmm.
Okay, no one else has any questions? I could look and see who's here. Cynthia, do you have a question?
I don't know. The last few videos really kind of solidified everything for me, so I feel
Okay.
pretty good about everything.
Okay, good deal. Okay, maybe I'm doing too good a job on the videos. I'll do less on the next lipid videos, make them harder.
No, that's okay.
Okay. Has anyone watched the lipid videos?
Not yet.
Okay, I didn't figure anyone would. I mean, I can see
have.
that some people have.
I
like-
watched all of them.
Oh, you did?
Yes, they're good.
Are they good?
Yes.
Okay. I know
I like the
48
review
people have
video.
watched them. What?
I like the review video, the third one.
Oh, the summary one?
Yes.
Okay,
Yeah, the
perfect.
summary is helpful.
Okay, good deal. I put the quiz up so you can take the quiz too now.
Okay, thank you.
You're welcome. Okay. Well, if you don't have any other questions, we can be done and I can go have my ice cream. Everybody's good? If you have questions, you can email me too. And you can group me or you can post them on YouTube. I try and check them twice a day. So, okay. Okay. You all have a good evening.
So thank you.
You
You're
too.
welcome.
Thank you.
Thank you.
Thank you.
Bye.
Thank you. Bye.
Bye.